Hello and welcome back to Cosmo 3i, where we don't just look at the pictures, we read the data that others ignore. Today we're diving deep into a mystery that has slipped through the cracks of the mainstream news cycle involving an object that broke every rule in the book. When 3i Atlas made its closest pass by Earth, nothing dramatic happened in the sky. No flash, no visible spectacle, no moment most people would ever notice. It was a phantom event, a silent passage that barely registered a blip on the public radar. And that silence is exactly why this moment matters more than the noisy headlines about standard comets. Because while the object is already moving away at tens of kilometers per second, heading irreversibly back into interstellar space, the data it left behind has only just begun to speak. We're left holding a collection of readings that defy the standard explanations for how a ball of ice and rock should behave. And what that data is telling us does not sit comfortably with what we expected to see from a simple celestial visitor. This wasn't a dangerous encounter by any traditional definition of the term. There was never any risk of collision as the object passed at a safe distance of roughly 270 million kilometers. But something about its behavior before, during, and after that passage has changed fundamentally, and we're already detecting the consequences. The object is gone, vanishing into the dark, but whatever happened did not end when it left Earth behind. The narrative that this was just another rock is crumbling under the weight of the telemetry. We're looking at a system that reacted to us, or at least reacted to our neighborhood in a way that suggests hidden complexity. The trajectory of 3i Atlas tells us one crucial thing right out of the gate. This object is not coming back, and it doesn't care about our solar system's rules. Its orbit is hyperbolic, meaning it is not gravitationally bound to the Sun and will never return to the inner solar system. Once it reaches the outer regions, it will disappear forever into interstellar space, carrying its secrets with it. In most cases, that departure would also mark the beginning of a slow and predictable decline in activity. That is what the textbooks tell us should happen as a body retreats from the warmth of a star. As distance from the Sun increases, thermal energy drops, sublimation weakens, and cometary behavior gradually fades into a frozen slumber. That is the standard model, the curve astronomers expect to see every time a visitor leaves the party. But 3i Atlas is not following that curve, and it is refusing to go quietly. Instead of a smooth decrease in brightness, telescopes are recording sudden increases followed by sharp drops, repeating again and again. This is not the behavior of a dying comet. It is the behavior of an active machine or a complex geological system. This is not random noise or a glitch in the sensors. These fluctuations are coherent, persistent, and most importantly, synchronized across independent observatories in different parts of the world. Chile sees it in their data. Hawaii sees it in theirs, and space-based platforms see it too. When different instruments separated by thousands of miles agree on the signal is real. Researchers have started using an unusual word to describe what they are seeing in the light curves. They're calling it a pulse, and they aren't using that word as a poetic metaphor. It is a measurable, rhythmic fluctuation in brightness and activity that appears shortly after the Earth flyby and continues as the object recedes. In normal cometary physics, activity decreases after perihelion because the heat source is moving away. The system cools, energy input drops, and the behavior stabilizes into a flat line. Here, the absolute opposite is happening before our eyes. The object brightens abruptly, dims, then brightens again in a repeating cycle that looks suspiciously like a heartbeat. The first instinct of any astronomer is to attribute this kind of signal to simple rotation. You assume it is just the spinning body with an active region briefly facing the observer. But the timing, regularity, and stability of these pulses do not match simple rotation models. If this were just a spinning rock, the curve would be smooth and sinusoidal. The data suggests something more complex, a combination of rotation, wobble, and internal imbalance that shouldn't exist in a simple chunk of ice. This implies internal structure, not a uniform block of ice and rock, but something layered, fractured, or unevenly distributed in mass. We're dealing with an object that has moving parts. Structurally speaking, it is shifting its weight, responding to stresses, and venting in a way that implies an internal architecture. Here is where the puzzle deepens, and things start to get really uncomfortable for the standard model. Despite signs of rotational complexity and wobbling, the jets associated with this activity remain remarkably precise. You would expect a wobbling sprinkler to spray water everywhere, but that isn't what we see. The jets do not fan out chaotically into a messy cloud. They do not disperse randomly as you would expect from a tumbling, unstable nucleus. They are narrow, directional, and repeatable, firing like thrusters rather than leaking vents. This is an unusual combination that usually points to a contradiction in our understanding of the object. In natural systems, rotational instability tends to produce messy, uncoordinated outflows. Precision usually comes from confinement, from a structure that forces the gas into a specific path. That confinement could be caused by highly structured emission points or by channels that guide material outward in a controlled way. It suggests that the surface isn't just cracking open randomly. It has specific vents that remain stable. In natural objects, strong confinement typically requires significant magnetic fields or deep gravitational wells. A small interstellar body should possess neither of those things at meaningful levels. We shouldn't be seeing magnetic focusing or heavy gravity shaping these jets. This does not imply anything artificial, but it does place immense pressure on existing natural models to come up with an answer. We're seeing instability and control at the same time, which is a paradox. It is a pairing that is not common in cometary physics and usually indicates we are missing a huge piece of the puzzle. The object is acting like an unstable top, yet firing like a sniper. The timing of this behavioral shift is not arbitrary, and that might be the most suspicious part of all. The onset of the pulse coincides closely with the moment 3I Atlas exited the region where Earth's gravity has its strongest relative influence. It waited until it passed us to turn on the strange behavior. This raises a subtle but important possibility that many researchers are hesitant to say out loud. Earth did not cause the activity in terms of heat, but it may have triggered it gravitationally. Even weak tidal forces can generate stress in bodies that are fractured, layered, or structurally complex. If the object contains trapped volatile pockets beneath a crust, those tidal stresses could produce episodic releases rather than continuous outgassing. It's like squeezing a sponge rhythmically. You get pulses of water rather than a steady stream. In this scenario, what we are observing is not a new phenomenon, but the latest iteration of a mechanism. It is a process that may have been activated many times before near Mars, near Jupiter, or even around other stars millions of years ago. Earth did not change the object's nature or rewrite its physics. It may simply have nudged an already sensitive system into a new phase of operation. Once the pulse was confirmed as real, attention shifted inward because rhythmic behavior almost always points to internal structure. A simple homogeneous body does not pulse like this. It just fades. If 3I Atlas were a solid uniform mix of ice and rock, its brightness variations would track rotation cleanly and predictably. Instead, the data suggests a system that is dynamically complex, potentially layered or fractured with uneven mass distribution. We might be looking at a honeycomb structure or a body with vast internal cavities. That kind of internal architecture allows stresses to build, release, and rebuild in cycles. This produces episodic activity rather than a steady decline, acting like a natural engine. The important detail is that this behavior emerged after the Earth's flyby, not before, implying the system crossed a threshold. It encountered our gravity, felt the squeeze, and shifted gears. Once triggered, the object didn't settle back into equilibrium like a normal comet. It entered a new regime of behavior that persists as it moves away, which is not what standard post-encounter cooling models predict. It's like a bell that keeps ringing long after it has been struck. At the same time, the outflows associated with these pulses remain sharply confined. Gas and dust are not spreading into a broad fan as they escape into the vacuum. They are being expelled along narrow, repeatable paths, maintaining their shape over thousands of kilometers. In natural comet systems, this level of collimation usually breaks down as activity weakens and structural coherence degrades. Usually, as the pressure drops, the jets get wider and softer. Here, the opposite is happening and the focus is tightening. As the object recedes and overall energy input drops, directional precision remains absolute. This suggests that the emission points are not random surface fractures, but stable, well-defined channels. These aren't just cracks in the ice, they are permanent features of the object's geography. Whether those channels are formed by internal layering, compositional boundaries, or long-lived cavities is still up for debate, but they imply a degree of organization that is difficult to reconcile with a loosely bound rubble pile. You don't get precise plumbing in a pile of gravel. The system appears dynamically unstable on a global level, tumbling and wobbling through the dark. Yet locally, where the material escapes, it is constrained and disciplined. It is a contrast that demands a better explanation than it's just a weird rock. Spectroscopic data adds another layer to this picture, and this is where the chemistry gets bizarre. The observed ratios of carbon dioxide and methanol relative to water vapor are unusually high. This points toward formation in an environment far colder than the Kuiper Belt, somewhere deep in the interstellar void. In such conditions, volatile compounds that would normally be lost early can remain frozen and preserved for billions of years. This object is a time capsule from a deep freeze we can barely imagine. This alone makes 3I Atlas scientifically valuable beyond measure. It represents a direct sample of chemistry from another stellar system delivered right to our doorstep. But then nickel enters the story, and the standard models start to sweat. Emission lines of nickel appear clearly in the coma, glowing in the spectral analysis. The problem is that iron, which almost always accompanies nickel in the universe, is weak or absent. Separating these two elements at this scale requires unusual chemical pathways that don't happen easily in space. You usually find them together like salt and pepper. One proposed mechanism involves nickel carbonyl, a volatile compound that can vaporize at relatively low temperatures in carbon monoxide-rich environments. The chemistry is plausible on paper, but seeing it in the wild is a different story. It has never been observed operating so cleanly in a natural object before, and even if the chemistry works, it still doesn't explain why the resulting outflow remains so narrowly focused. You can explain the gas, but you can't easily explain the gun it's firing from. The presence of exotic chemistry combined with exotic structure is a lot to swallow. Then there is the anti-tail, a feature that has scratched the heads of observers everywhere. In standard comet physics, material is pushed away from the sun by radiation pressure and solar wind. Everything should be flowing downstream away from the light. Apparent sunward tails can sometimes be explained by viewing geometry, an optical illusion caused by the angle of observation. But here, geometry alone does not resolve the observations we are seeing. The math doesn't add up to a simple trick of the light. The data suggests a physical flow of material moving at least partially toward the sun, resisting forces that should disperse it. It is fighting the solar wind, pushing upstream against the current. Even more striking, that flow is persistent and collimated. Gas expands, dust spreads, but narrow streams require shaping and forcing. This does not imply an artificial origin, but it does demand a shaping mechanism we do not yet fully understand. Something is focusing this material and shooting it against the flow. It is at this point that many existing models begin to strain and crack. They are not necessarily wrong, but they were never designed to handle an object with this combination of chemistry, structure, and dynamical behavior. We are trying to fit a square peg into a round hole. What's becoming increasingly clear is that whatever changed during the Earth's passage did not simply fade away once the object moved on. The event wasn't a temporary glitch, it was a state change. The pulsing behavior continues as 3I Atlas recedes, which implies the system has shifted into a new operational state. Rather than experiencing a brief disturbance, it has unlocked a new mode of being. In physical terms, this suggests a threshold was crossed. Once internal stresses were released or internal pathways were opened, the object did not reseal or stabilize. Instead, it settled into a repeating cycle like a mechanical system that has slipped into resonance. Natural bodies can do this, but it usually requires a very specific internal configuration. It needs a structure that stores energy and releases it periodically like a geyser. The persistence of the signal tells us this is not a transient flare that will burn out in a week. It is an ongoing process that seems self-sustaining for the time being. The object has found a rhythm, and it is sticking to it. Earth's gravitational influence is weak compared to the Sun's, and skeptics will point that out immediately. But weak does not mean irrelevant, especially in chaotic systems. For a body that is fractured, layered, or internally complex, even small tidal gradients can act as a catalyst. The timing strongly suggests that the object's exit from Earth's zone of strongest relative influence coincides with the onset of the pulsing behavior. It's too perfect of a coincidence to ignore. This doesn't mean Earth caused the activity in a direct sense, like lighting a match, but it may have acted like the final tap on an already stressed structure, the straw that broke the camel's back. In this context, Earth becomes part of a longer chain of interactions. We are just the latest stop on a very long tour. This chain acts as one that may have included close passes by other planets or stars long before this object ever entered our solar system. It has likely been shaped and reshaped by gravity wells for eons. What we are observing now could be the cumulative result of repeated tidal interactions over millions of years. As more data is analyzed, it becomes harder to fit 3I Atlas into existing cometary models without extensive modification. We are having to rewrite the chapters on interstellar visitors in real time. Standard models assume relatively simple internal structures, gradual thermal responses, and predictable post-perihelion behavior. Here we see abrupt changes, rhythmic activity, precise outflows, and chemical signatures that diverge sharply from expectations. It is a laundry list of anomalies that just keeps growing. Every time we think we have a handle on it, the data throws another curveball. Each anomaly can be explained in isolation with enough assumptions and mental gymnastics. You can find a reason for the nickel, a reason for the pulse, a reason for the jets. But when combined, those assumptions begin to pile up into a tower of instability. This is often a sign that the model itself is incomplete or fundamentally flawed for this specific class of object. It is not wrong for solar system comets, but it is built for a narrower class of objects than what we are seeing here. We are applying local rules to an interstellar traveler. Interstellar objects formed in environments we've never directly sampled may simply fall outside the comfort zone of those frameworks. We have to be humble enough to admit that our backyard physics might not apply to the whole neighborhood. 3I Atlas is teaching us that lesson the hard way. Beyond the specifics of this object, 3I Atlas is forcing a larger realization upon the scientific community. Interstellar objects are not just fast-moving curiosities that briefly pass through and leave. They are complex worlds in their own right. They can be chemically rich, dynamically active, and structurally complex even after leaving the region of strongest solar influence. They are not dead rocks, they are active archives of galactic history. The fact that this object was discovered relatively late in its approach highlights how easily such visitors can slip past our detection systems. If 3I Atlas had been slightly smaller, darker, or faster, none of this data would exist. We would have missed the entire show. The implications extend beyond this single case, painting a picture of a busy universe. It suggests that the galaxy is not a quiet backdrop, but an active environment through which material regularly moves. It interacts, it evolves, and occasionally it surprises us. We are living in a cosmic intersection, not a deserted island. One detail that keeps resurfacing in the data is coherence. And this is the thing that keeps astronomers awake at night. The pulse is not drifting, not decaying, not desynchronizing as the object moves farther from Earth and the Sun. It is keeping time perfectly. Instead, it remains remarkably stable in both timing and amplitude. In astrophysical systems, coherence over time is difficult to maintain without an underlying structure enforcing it. Chaos usually takes over eventually. Random outgassing produces noise, not music. Thermal relaxation produces smooth curves, not sharp beats. What we are seeing instead is a repeating pattern that survives changing external conditions. That tells us the driver of this behavior is internal, not environmental. The object is not reacting passively to its surroundings anymore. It is driving the bus. It is operating according to its own internal dynamics, and that alone makes it an outlier among known cometary bodies. The pulse has also allowed researchers to infer aspects of the object's rotation that were previously inaccessible. We are using the light curve to map the motion of the body. The data does not support a simple spin around a single stable axis. Instead, it points toward a combination of rotation and wobble, a complex motion that implies uneven mass distribution. It's tumbling through space like a poorly loaded washing machine. This is exactly what you would expect if the interior were layered, fractured, or contained cavities of differing density. Such internal heterogeneity would explain why stresses accumulate and release episodically rather than continuously. The internal structure is acting like a stress battery. Importantly, this kind of structure would also allow channels to remain stable even as the bulk motion of the object becomes irregular. This resolves the apparent contradiction between global instability and local precision in the jets. The body can tumble all at once, but the vents are fixed. It is a mechanical solution to an observational paradox. Another implication of the current behavior is memory. We are talking about physical memory, not conscious memory, but structural retention of past events. The object appears to respond not just to present conditions, but to accumulated history. If tidal interactions during the Earth flyby were sufficient to trigger this new phase, then similar interactions in the past may have left lasting imprints. It remembers where it has been. Close passages near other planets, near its parent star, or even through dense interstellar environments could have progressively shaped its internal architecture. What we are observing now may be the final expression of a long evolutionary process. It is the climax of a story that began long before this object ever entered our solar system. In that sense, 3I Atlas is not just passing through space, it is carrying a record. It is a physical hard drive of every significant gravitational interaction it has ever experienced, and we are just now trying to read the files. Perhaps the most unsettling aspect of this phase is that the object is leaving while still active. Most comets quiet down as they retreat, becoming observationally uninteresting long before they disappear from view. They fade into the background noise. This inversion of expectations means we are watching a system evolve in reverse. It is becoming more complex as it exits rather than simpler. In observational astronomy, that is a dangerous situation because it creates a race against time. It means the most important data may arrive when the object is already becoming too faint to study in detail. We are losing signal just as the signal gets interesting. The clock is running, and every new pulse detected is a reminder that whatever changed did not end with the Earth flyby. We are watching a mystery unfold in the rear-view mirror. Another striking feature is endurance. The channels guiding material outward do not collapse as activity continues. In fragile cometary nuclei, sustained outgassing usually widens vents and destroys the nozzle. Erosion usually leads to a progressive loss of definition. Here, the opposite appears to be happening, and the geometry is holding fast. The jets remain narrow and repeatable over time, implying that the pathways confining the flow are mechanically robust. This suggests a material strength higher than expected, or a geometry that naturally reinforces itself under stress. It is built tough. Either way, it challenges the idea that this object is a loosely bound aggregate of fluff. Whatever its internal makeup, it behaves as if it possesses architectural integrity. Even while undergoing dynamic internal changes, it is shaking itself apart yet staying together. The regularity of the pulse hints at resonance. In physics, resonance occurs when a system naturally oscillates at a preferred frequency due to its structure and energy distribution. It finds its groove. Once excited, that oscillation can persist with minimal external input. The Earth flyby may have provided the initial excitation, the kickstart, but the persistence suggests the object has an internal configuration that supports sustained oscillation. It was built to ring. This is not something we typically associate with cometary bodies, which are usually damped systems that lose energy quickly. They're usually thuds, not bells. Resonant behavior implies compartments, boundaries, and feedback mechanisms. All of these are hallmarks of structural complexity that we don't usually credit to space rocks. Again, this does not point to intent, but it does point to organization. It is an organized system in a chaotic void. As these behaviors accumulate, a gap opens between what we observe and what we can comfortably explain. That gap is not a failure of science. It is the breeding ground for discovery. It is the beginning of real understanding. The continued monitoring, the extension of observation windows, and the reanalysis of earlier data all signal that the scientific community recognizes this tension. They know something is up. When an object forces multiple models to stretch at once, it becomes a priority case. Not because it is mysterious in a sensational sense, but because it exposes blind spots in our knowledge. 3i. Atlas is doing exactly that, shining a light on what we don't know. What we are seeing after the Earth flyby is likely not a new phenomenon, but a delayed revelation. It is showing its true colors on the way out. A system pushed past a threshold, settling into a mode of behavior that reveals its internal architecture rather than hiding it. It is finally opening up. Pulses instead of decay, precision instead of chaos, activity that persists even as the object retreats into the cold. These are not violations of physics, but reminders that physics can play out in ways we have not yet cataloged. When the initial conditions are unfamiliar, the results can be shocking. 3i Atlas is already on its way out. Its orbit guarantees there will be no second encounter, no easy follow-up years from now. We don't get a do-over. Soon it will become too faint to study in detail, and eventually it will vanish completely into interstellar space. It will be a ghost in the database. What will remain are the records, the light curves, the spectra. We will have the timing of those pulses and the uncomfortable questions they raise. Was this an extreme natural case? Almost certainly. Was it normal? Clearly not, and that distinction matters more than anything. Even the questions posed by Enrico Fermi come to mind. If the universe is so vast, where are the unique signatures? Maybe they are just passing through, disguised as rocks until they start to pulse. We need to be ready for the next one. If you want to stay updated as new data comes in and as future interstellar visitors challenge our understanding even further, make sure you're subscribed to Space Nest, because the next object like this may not announce itself clearly either. And by the time we realize what we're looking at, it may already be on its way out again. Stay curious, stay skeptical, and keep watching the skies.